What are you doing?
We're seeing the mass of this.
What is that?
That's 50 milliliters of vinegar.
Vinegar. All right. Is vinegar an acid or a base?
Acid.
Acid. Very good.
This takes so long for a number.
That's good.
Okay.
Wait.
No, it's not.
So how much does 50 milliliters of vinegar weigh?
We're deciding that right now. Yeah, I think.
There. That's good.
So it's like 7.7. No, wait, 117.
117 point what?
7 question mark?
7, and then you can guess that next spot, right?
7.
7. 117.77.
Yep,
Perfect.
that's what we'll go with.
Now we don't need to worry about erasing out the weight of the beaker because we're going to measure it again, and the beaker will be in both of the weights. So then the difference will be the amount of vinegar that we used. So, all right, now what?
Okay.
We have to make up the what goes in the other beaker.
Yeah. It's 10 milliliters of
Ammonia.
And ammonia is an acid or a base?
A base?
A base. And if we put 10 milliliters of ammonia in there and then add some water, what's that called?
Dilution.
A dilution. You're
Yeah.
diluting the strong base with water.
This is what this shows. For no reason. I'm spelling everywhere. Yeah.
Bless you.
That's it.
Thank you.
Go over the sink.
Yeah.
It's got ammonia all over my fingers.
That's okay. You should probably wash your hair.
And for those who aren't going to watch this video, you don't get the full effect without all of the smells. Because vinegar just smells so great, and ammonia is even greater, and the best of all is our indicator. What's our indicator?
Cabbage water.
Cabbage water. What exactly is an indicator again?
That's a thing to indicate whether a thing is a acid or a base.
So you can tell if it's an acid or a base by the
Color.
color change. Very good. So if something's an indicator, it changes color in the presence of an acid and a base. Probably you should remember that.
It's gonna make me pass out.
Okay. So 10 mils exactly, 10.0 mils, right?
Yeah. And then the rest,
How much is the rest?
that would be 9.0 milliliters of water.
All right, so you're filling it up to 100 then?
Yes.
Way too much. No, wait, it's good. It's perfect.
Okay, perfect. And you're gonna weigh that. And now, this time, this is the second time we're doing this. And we're going to see exactly how much.
100.
Did we record what we were supposed to record of the other things? The weights of things on your lab paper? You might want to look at your lab paper and see if you recorded what you were supposed to record. So I sent everybody this lab directions and also the slab paper. So the slab paper is going to be counting as your results, right? But make sure you still tell me about your description and your conclusion. And you might want to tell me about a dilution and what a indicator is in your conclusion. Okay. How much does your water and ammonia weigh? 211 point something something, because you can read to the hundredths place on that scale. 01 grams of ammonia water, diluted ammonia water.
Where do I write that again?
It should be up at the top. All of the things that you're measuring should be up at the top. Now we are doing it again. And we know that it's going to be around 11 mils that we're adding. And the color is greenish. And we're looking for when it turns to
Purple.
when it turns to purple. Or a pinkish purple. And we know it's going to be about 11 mils. So right now, the greenish blue means that is what again?
No, base.
B for base, blue base. That's green, but green and blue is base. And that's going to turn either pink or purple for an acid.
5.
Like our red litmus paper last time was acid.
6. 7. 8. 9.
So stir, stir, stir.
10.
I feel like it's more green than last time.
And then next,
We didn't use 10 drops, we used 10, 11
Oh, I thought we
mils.
used. Oh, we're almost at 11 here.
We were like right under the 40.
so it's still a base, it's still a base, and at the end of titration is where you have enough acid to eat up that base. So again, we're getting very close to the end of titration, where your acid is going to eat up all your base, and you should see a color change. How close are we?
Like, should be the last one, theoretically. Okay, I guess not.
It does look a lighter green. Oh, is it pink?
It does not look like it.
Doesn't look green anymore.
It
Yep.
really needs one more.
I think that looks pretty pink or pinkish purple to me.
Does it?
No.
There we go.
There we go.
Alright, so now you're going to want to weigh how much acid you had to use. So we know how much acid ate up the base. How much acid did you use?
That looked right to everyone else.
Sure.
What is it?
It's 106.6.
106.67.
Yep,
Yeah.
grams.
All right, so one of the things we need to know is that molarity, which they write as a big M, which is going to be confusing next week when we learn something with a little m. But big M now equals molarity, and that's how many moles per liter we have. And we're going to figure out how many moles per liter are the molarity of something we have today. So how much vinegar did you use in your rough titration, the step 9 on the top there?
11 milliliters.
So you used 11.0 milliliters. And how about the amount of ammonia in milliliters?
10.0 milliliters.
So 10.0 milliliters. So this one is vinegar. And this one is ammonia. Okay. So what was the mass of your cylinder and 50 milliliters of vinegar?
117.77 grams.
This is mass of cylinder and vinegar, 50 ml of vinegar is, I'm sorry,
117.77 grams.
All right. And how about the mass of the cylinder and remaining vinegar after you dropped it out? So I'm going to say remaining vinegar.
106.67 grams.
All right, so if we subtract these numbers, we're going to figure out how much vinegar we used, and we'll do that in one of the other steps. But okay, so this is, we did a titration. The whole point of that is to see the color change when enough acid eats up the base that we have. That's called the end point of your titration. And I wrote the reaction there, the acid plus the base, and it ends up giving you some ions. So we need to figure out how many moles per liter we have. To do that, we can figure out the amount of milliliters because we know how many in one liter of ammonia, you can figure out how much of a liter you have. We have how many milliliters we have. So if you take milliliters of ammonia times in 1 liter, you take divided by 1,000 milliliters. So how many milliliters did we have of ammonia?
10.0.
So 10.0. So divide that by 1,000. So 0.0100 liters of ammonia. Okay. So when you're doing molarity, you need to know how many liters you have, not how many milliliters you have. Just remember to do that conversion. And now we need to figure out how many moles of ammonia we had. So we're going to figure out, we're not going to figure out how many moles of ammonia we had directly. We're going to figure it out how much of it got eaten up, because if we look at our reaction, you have 1 mole of this to 1 mole of this gives you your change. So it should be a 1-to-1 ratio. So if we figure out how much vinegar we have, we should be able to say that's exactly how many moles of acetic acid we have. Of ammonia we have. So we're going to figure out how many grams of vinegar we have. Do we know how many grams of vinegar we used? You're going to subtract those two numbers. I don't have a calculator, so I'll have to actually do it. 0, 1, 1, 0. No, that's not right. 7, 1, 1. This is a 1. And that's a 0. So
11.1.
So 11.10 grams of vinegar. So that's this step here. It's how many grams of vinegar you have. So now we need to figure out. We didn't use pure vinegar. We used vinegar. We didn't use pure acetic acid, which is what our reaction is. So on the bottle, it says that we have to multiply by 0.05. It's 5%. So we have to take that and multiply it by 0.05 to get how many actual grams we have. So you're going to multiply that by 0.05, And I can't do that one. I'm gonna cheat and get my cup. 11.1 times 0.05. So we have 0.555 grams of vinegar. 0.555. People can see that, maybe. 0.555 grams of vinegar. Okay, let's start higher. So now we're flipping to the next page. So we know how many grams of vinegar we have. So now we want to find out how many moles we have. So we have to convert that to moles. And we have to go back a couple chapters in our brain of how we do that. So remember that number on the periodic table that they told you was AMUs. We could care less how many AMUs it is, because we can know also that that's how many grams per mole something is. So you have to figure out in acetic acid, you have 2 C's, you have 4 H's, you have 2 oxygens, and you have to figure out how much all of that is to add up to how many grams 1 mole of acetic acid is. So 2 carbons is 24.0 grams per mole. 4 hydrogens is, if you find in your periodic table, it's 1.01, so it's 4.04 grams per mole. I'm cheating there. And oxygen is 16, so it's 32.0 grams per mole. So if we add all that up, acetic acid is 60.0 grams per mole. Great. So we take what the acetic acid that we used, which we decided was 0.555 grams. We multiply that by how much 1 mole of it is, and we want the grams to cancel out on the bottom and the mole to be on the top because that's the unit we want to go to. So in 1 mole of acetic acid, it is 60.0 grams. So my grams are canceling out. I'm going to divide by 60. So 0.555 divided by 60 gets me how much, how many moles of acetic acid I used. And that should be 0.00925 grams per mole. I have 3 significant digits here, I have 3 significant digits here, so I should have 3 significant digits in my answer. Those are zeros. Did I lose anybody? Lost paper. Okay, so this 60 was this first answer here. This 0.00925 is the second answer here, your moles of acetic acid. Now here's the reaction again. For the acetic acid and the ammonia, when they mix together, there's 1 mole of acetic acid for every 1 mole of ammonia. So if I know that at the end point of titration, I used this much acetic acid, that's how many moles I had, then I should use that exact amount of moles of ammonia because it's a 1-to-1 ratio. Does that make sense? So remember, at titration is showing you when the amount of acid eats up the amount of base. And in my reaction here, it's a 1-to-1 ratio. So if I have this much base, then I have that much acid that's eating it up. So how much? So then it says, now we have everything we need to find the molarity of the ammonia. Here's the equation. So molarity equals 0.00925 moles. This is, I'm sorry, it's not grams per mole, it's a lie. It's a mole, because the grams got canceled out. So that's how many moles. And we have to go back to how many liters we had. And remember, we had 10 milliliters, so that's should be 0.001. Right, 10. .01 liters. and you drink. Because 10 mils equals 0.01 liters. So what's our answer then? If we take that number divided by that number. Yes, I'm dying. Anybody have a calculator? No? Nobody? Oh my goodness. 0.00925 over 0.1. My molarity then, which is my moles per liter, equals 0.9224. It should be 25. I should multiply it correctly. And then it's big M, molarity. So this one only has 2 significant digits, so it should really be 93. Okay? So that means how strong something is, how many moles per liter. That was our calculated the molarity of the ammonia. Okay? Yay! So what do we care? Why do we care? One, we can know that if we weigh something, we can calculate how many moles we have. Because of the periodic table, that little number on the bottom of each box tells us how many moles, grams per mole we have. So we can weigh things in the lab and convert that to moles. 2, we can figure out, once we figure out how many moles we have and we know how many milliliters we have or liters we have, we can calculate the strength of that acid or base. That tells us the molarity, okay? Moles per liter. What else did we do in this lab? We did a dilution. We took something that was strong, we mixed it with water, we made it less strong. That's a dilution. Also, we used an indicator. What's an indicator? Something that changes colors when you're in the presence of an acid or a base. So know what an indicator is. And ours today was cabbage water. Okay, let's see, time. Oh, I'm out of time, but I'm going to do one more problem. Because on your test, you're going to need to know a dilution equation. So we did a dilution in class. When you added water to something, the dilution equation is M1V1 equals M2V2. So the moles times your volume, the molarity times the volume of one thing is going to equal the molarity of your second volume. So that's what we did. We did something strong and we mixed it into a bunch of water. So we changed the volume and that changed the molarity. So if you go from something strong, you can't really make something stronger. You can make it weaker when you dilute it. So let's do an example, 10.5. The chemist wants to dilute 12.0 molar hydrochloric acid to make 500 milliliters of a 3.5 molar hydrochloric acid. So this is the amount, the volume of the strong solution. And I'm going to make this molarity a weaker I'm sorry, that's my volume. That's my volume and of the weaker solution. So it's this very strong solution, 12 molar, going down to 3.5 molar. So the unit of this volume is just going to be whatever unit this one is, unless they tell you differently, but to change it. But you can just assume that they wanted in milliliters then. So how do you do that? So you just rearrange this equation. So I have 12.0 mole times your original volume. How much of it do I have? Do I use to make 3.5 moles of 500.0 mils. So I'm just solving for this unknown. So I get rid of that 12.0 molar. That means I divide this by 12.0 molar because that cancels out. So I'm left with how much of that strong solution to make a big amount of a weaker solution. So I take my calculator. It's an order of operations problem. I have to do this times this and then divide by this. So make sure you do the multiplication on the top first. 3.5 times 500 equals divided by 12 equals. So how much should you use? You should use 145.8333. These molars cancel out. This is milliliters, but this is only 2 significant digits. This is 4, this is 3. That means I only get 2.
Bless you.
So I gotta round this to 2 significant digits. So I look at this number. If it's 4 or less, I round down. If it's 5 or more, I round up. So 140. I take 140 milliliters of the strong solution, fill into a beaker, add water to fill up to 500, and then I will have a 3.5 molar solution. That's exactly what you did. You took 10 milliliters of a strong, I don't remember, what is it? That was your ammonia, right? Your base. And you added water up to a certain mark. And so you made more of a solution that was less strong. That's a dilution. Okay? Okay. Sorry I ran over.